for specific year for my home university, it turned 125, and I want to use this chance to say thank you to all professors for their hard work and for a unique environment that helped me to build base ground for my passion and for my career. Yeah, and basically I graduated 14 years ago, and since then I was working in commercial sector. So in my story today, there will be a really poor amount of science. It will be about way of thinking. The way of thinking that helps to people to collaborate, especially with people with different background, and also to bring great ideas to production and make them work. The plan for this meeting is pretty strict. First, around 5 minutes, we'll talk about things you all know perfectly, so no new information, just to align our thoughts. Then we'll talk about some common sense, and after each you could ask questions. So pretty strict like that. And I would like to start from thinking about what is model. And usually we define a model as certain approximation of processes in environment. Second, yes. To approximate those processes, we need several components. And first component is architecture of model. It might be neural network, might be a decision tree, it might be simple regression, but we do need certain mathematical abstraction that would define a connection that we are looking in for in certain environment. And of course, architecture itself doesn't work. We need certain artifacts, basically coefficients that defines how this model works. It might be some tensors, it might be predicates, so something that would define behavior of our system. In most common case, we don't try to model a random process. We want to model a certain process, right process. And to train our system on the right processes, basically we need a certain quality function that defines our optimization goals. It might be loss function, it might be likelihood. In some critical cases might be an expert that sit next to you and say that this is work, this is not. But then it wouldn't be really machine learning. And we need too far. And we also need a certain way to iterate through this optimization function. It's well-known gradient boosting, backpropagation, etc., etc. We're not talking about exact algorithm. We need a way how to iterate and to find an optimum. And this is our second component. After it, after we defined our model and a way how we apply it, how we optimize it, we also want to apply it on something. And our environment and processes, they are usually represented by data. And it could be presented in tables as time series, images, and just as a concept. Of course, talking about data, we need to mention some pre-processing, so feature engineering, some filling empty gaps, etc., etc. We're not stopping on details, but I think you all know that from different sources, so no need to discuss. The trick is that usually people focus on these three components, and focusing on those, you will get really nice, precise model, and usually with really great accuracy, which has really high chance to fail when you go to reality. Because in reality, a lot of things that are not taken into account in these three components. And so you get infinite possibilities what could go wrong, and usually goes. I have nice example when we released recommender engine for our website, and this engine started recommending fireworks after football match tickets. And initial results were really good. They perform 8 times better than average. Well, we were curious why, but we were happy of margin. It happened. Then later we found that this particular team was fined by association because their fans use fireworks on their football match. Okay, well, we got short-term results, but long-term they doesn't work. And there is a pretty simple framework. How can we align what things we are doing and all these tricky moments and foresee some of those just to avoid a lot of misalignments, basically. And usually we call it ML system design. And this is basically what you do before you start designing your system. Well, a key concept of understanding it is that business don't think in terms of accuracy. They think in terms of business efficiency and return on investment. If you are doing something, there should be chance that it will improve process, it will get new knowledge to improve quality of decisions, or you develop certain model that will take responsibility about a certain domain. And usually all this ML system design process is split into two separate parts. First is writing functional requirements, basically understanding what your system should do. Well, we can say that it's simple, it's clear. It's not clear every time and we start with really general question, what we want to build and why. Just short story to show that when it's not clear. Some time ago, I was working on a system for basically graph structure to organize our assortment in association groups, so we can use it on our website to run some models on top of it, etc. The trick is that when we go to salespeople and ask how should it look like, they give us pretty strict criteria. They thought that it should look like the same as products are organized worldwide, so in a certain groups, in certain sectors of manufacturing. When we went to a front end to people who actually develop functionality to for our customers, they say, okay, we need some graph that will perfectly describe how we show to our customers, basically per category, and how they use it for garden, for some tickets for a weekend, etc. And we, as a team who ran auctions, basically were interested in similarities in product behavior and some elasticity, etc. We end that we need 3 different systems for that. So we can't solve it with one, because solving it with one would mean that basically no one will use it properly. And defining those moments could help you to select right architecture, select right requirements, and set business expectations, set optimization goal, and select loss function, and also to get what data do you really need. Next stage is to define corner cases. What you will do when your system fails. And that's pretty often, because in reality, system could cover only a certain small domain. Okay, sometimes not small, sometimes most cases it tries to cover about 95%, but still there are a lot of cases that are not there. What are business limitations there? Because it's pretty often you would see that people want to put their expertise in advance and set some boundary conditions, or to have control of the process. And it's pretty wise to use that experience, because it will narrow down the amount of errors you will do. And of course, it is about thinking how your mistake cost. Just think about classification problem. If you do classification for corona test, in a case, so you have binary classification, pretty simple task, but you might make two types of errors: false negative and false positive. If you do false positive for corona test, the person will stay at home for a certain time. If you do false negative, the sick person will go and spread disease through population. So the cost for entire system is completely different on this spot. So you might want to use not some standard F1 score, but something weighted and to adjust it. And of course, last step about functional requirements is to think what would it mean in production, how you will retrain, because if you put model to control certain process, it will bias data set in future. You can't directly reuse data. For example, recommendation engine we built produce on send traffic only to cases where we think are important. That's why we can't reuse this traffic for further decisions. How we test it? And because, well, let's be honest, business is not interested in accuracy. It is interested in money, in quality decisions, and usually people use split test framework to do that. By splitting website to two equal parts, they just want to know what is the difference between them. But you can't do that in physical world. You can't do it in certain cases like with prices. And of course, you need to monitor all these things. Going through all these steps, you will get enough information actually to write a non-functional requirements, and they are pretty strict. So how fast is your system, and should it be fast or not? How secure is it? Because in a lot of countries there is legal restrictions of what you can do with data, what you can't, and you definitely don't want data leakage and share some private data with the rest of the world. And of course, you need to think, well, what would be an effect, and would the effect be expected effect above resources you will spend to develop this system? The irony is that this system looks pretty close to a common bureaucratic process of practical applications, like writing a goal, methods, object of research that personally I hated when I was a student. But practice shows that it's the most common bridge between good idea and useful tool that people will use. Thanks a lot for your attention, and please ask questions.
Thanks, Mitro, for very